Hello everyone, I welcome you all in the next lecture of 12th NCERT Mathematics. In this lecture, I'll discuss question number 11th of exercise 1.1. For this question 11th, we have two parts. In this first part, we need to prove the relation R. This relation R is defined. See the length of the relation is an equivalence relation, okay, on which set A points in a plane, okay, and further we need to prove that we have some point P which is non-origin point, okay. So we need to prove that the number of elements related to P, the collection of all the elements related to P form a circle, okay. So first of all I will prove A part. Now what the A part said? First of all, the set A. What is set A? Set A is the collection of all the points such that x and y are real number. Are real number. It means they are in Cartesian plane. They are in Cartesian plane. This is x-axis, I assume, and this is y-axis, I assume. Okay. So in a question, they define a relation R on this set A, and how they define? P point we have, Q point we have. Okay. These P comma Q, ordered pair P comma Q belongs to R if the distance of the point P, let us assume it is O. Okay, for the simplicity, let us assume the center O is, the origin is O. Okay, so they said that OP equal to OQ. Okay, in a simple manner we can write, otherwise it will be a time wasting, okay, if I am writing the complete language. So actually the relation R is, it collection of all the ordered pair P comma Q. Okay, P is a point in the xy plane and Q is also a point in the xy plane, such that the distance of the point P from the origin is equal to the distance of the Q from the origin. Okay, so actually point P is also like some A1 A comma B type, okay, and point Q is also same as that C comma D type. Okay, that is because these are the 2 points. Now these are the representation of in a Cartesian plane. Okay, now for reflexive we need to prove, for reflexive, first of all we need to prove reflexive. How we can prove? First of all we need to take an arbitrary element of A. So let us I choose, let P belongs to A. Okay, if P belongs to A, okay, then observe OP equal to OP. Why so? We need to write distance of point P from origin is same as distance of point P from origin. Actually they both points are same, so that's why I'm writing this language. Okay, so it means that what it implies? It implies that P comma P belongs to relation R. Okay, so P is a, here you can observe from here and here, P is an arbitrary element of A. That means any element in the Cartesian plane or in xy plane if I am taking, then obviously P comma P belongs to R. Okay, so it implies that R is reflexive on A. We can prove here. Okay, now the next one is symmetric we need to prove. I'll change the color. For symmetric. For symmetric, what we need to assume? What we need to assume here? Let P comma Q belongs to A. Okay, first of all we need to assume two element of A. Okay, and one more thing we need to assume that P comma Q belongs to R. I assume the elements in the form of P comma Q because here the elements of A are the points in the xy plane. That's why I'm choosing by capital P and capital Q. Okay, now P comma Q belongs to R. If P comma Q belongs to R, then it means OP equal to the OQ. Distance of a point P, distance, suppose I will explain by the example. Suppose point P is here and point P Q is here. I will take hypothetical, okay, and here your O. So observe that they said that P comma Q belongs to R because this distance from here to here and from here to here both are same. That's why OP equal to the OQ obviously, and hence P comma Q belongs to R. Okay, now also if this thing will happen, then also OQ equal to OP, and hence Q comma P belongs to R, implies that R is symmetric or not? Symmetric on A. Okay, now for transitive we need to prove. For transitive we need to prove. For transitive what we have? Let what we can assume? Yeah, P Q M, P Q and M belongs to A set, belong to set A. It means that P Q and M all are 3 points in the Cartesian plane or in xy plane, with what we need to assume also? P comma Q belongs to R and Q comma M also belongs to R. Now if P comma Q belongs to R, then the distance from the origin of point P is same as the distance of the point Q from the origin, and here also OQ equal to the OM. Now this one I assume third and this one I assume fourth, so I'll say from third and fourth we have OP equal to the OM. If OP equal to the OM, then it implies that P comma M belongs to relation R. Okay, so here it implies that R is transitive. R is transitive on A. Now it implies that here I can write final answer that R is an equivalence relation on R is an equivalence relation on A. Okay, first part is proved. Now second part, B part. What is second part? Second part, in short I will write. Second part, actually we need to find, we have, suppose first of all we have this thing, P is not equal to 0 comma 0. That means in this Cartesian plane, okay, in this Cartesian plane, yeah, except this point, that is 0 comma 0, we have some point P in any in complete Cartesian plane or in XY plane except origin, and we need to find class of P, or this one we can say, or P bar. So how we can find? See here, actually it is the collection of all those elements of A such that Q, those who are related to P, those who are related to P, class of P. What is the meaning of class of P? Class of P, this is the same thing, na? So it means that Q belongs to A, Q comma P belongs to R. Step by step I will write, okay, so that you can understand. Q comma Q belongs to A. Now here you can observe Q comma P belongs to R. It means that if Q comma P belongs to R, then it means that OQ equal to the OP. Okay, OQ equal to the OP. Now, so it means that, what is the meaning of that? Class of P. If we observe this thing, then it means, suppose, listen here. Yeah. Suppose point P is here. Hypothetical I will take. You can take here, maybe here, maybe here, maybe here. I'll take here, okay. This is point P. And I need to choose those points of this complete Cartesian plane. Suppose this is a Cartesian plane, XY plane, okay. From this we need to choose, I need to choose all those points, okay. I need to choose all those points whose distance from the origin is same as that of P, is same as that of P. So this point is also at the same distance. This point I will collect, and this point I will collect, this point I will collect, this point I will collect. So if I am joining all these points, okay, if I am collecting all these points, these point, these point, after collecting all these points, you understand what we get? We collect this point we will collect, this point we will collect. Why so? Because this distance and this distance, okay, this distance and this distance has to be same, both are same, that's why. So because we know that definition of circle. A circle is a closed curve in which all the points are equidistant from a fixed point, and the fixed point is called center. And these points, all these points which are on the circumference, which are here, are at a fixed distance or equidistance. All these points are equidistance from a fixed point. So if we collect all these points, we get a circle centered at origin, centered at origin. So this is a class of P. Moreover, if P is any point except origin, then we got the same thing, okay. So I hope you understand this question. If you have any doubt, then you can do comments. I will reply as soon as possible. Thank you for watching.